Now in this lecture, we're going to do a more real-world example, and we're going to use the IRIS data set that we've been using throughout the other lectures. So let us start by reading in. We're going to need this library ggplot for some graphs that we're going to do. So let's load that in. And we're going to, of course, need flexclust. So let's grab that guy. And there you go. So we brought those two in. And something else we're going to want to do is, for this example, we are going to have a training and a test data set. And we're going to do this for demonstration purposes to show that clusters can actually be used for predictive modeling. So let's start off by reading in the IRIS data set. And now we're going to use this command here, sample, and it's going to sample the, we have the number of rows here, which is going to be, I think there's 150 rows, and this end sample is going to select 30 of them randomly. I've just decided to randomly select 30 for test purposes. So that's what that command does. So if I type in end sample, these are the random samples that are selected. So this would be iris number 68 and iris number 129, and these are going to be the ones we're going to test on. So this is what the data set looks like right now. So we've got, and if, in fact, we've got 150 of these flowers, as we've seen it all quarter long. And what we're going to do is we're going to set this new variable to true. We're going to create a variable called train, and we're going to set that to true. So if I do, you can see I've got this guy all set to true. Now, what we're going to say is if this guy is one of the end sample ones, remember we had 30 of them selected, any of those guys are going to be set to false. Right now they're all set to true, but we're going to set the sample guys to false. Whoops. Okay. So if I do, let's just type them all in there, df. You can see that some of them are set to false. So some of these things are going to be set to true. The training ones are some are going to be for training, and some are not going to be used for training. We've set those ones to false. So that's what we did there. Now let's just break this thing down into two data sets. So what we're going to do is we're going to say the data frame where it is set to true, and we're going to take all the columns and we're going to shove those guys into df train, and where they're set to false, we're going to set that into df test. So let's do that. And if I do the head command here, you can see that the training data set, they're all set to true. Whoops. And for the test data set, they're set to false. So these guys are not in here and these guys aren't in there. So I've split the data set into a training data set that we're going to cluster on, and we're going to test on this guy here. Now, because we don't need these things anymore, let's get rid of them. And just to show you that they're gone, there they are. So now we've got a training data set and a test data set. Now we're going to cluster, and we're going to cluster on 4 variables. all 4 of these guys. Now, how many clusters are there? Now we know that there's 3 species, but let's say we didn't know that. I mean, maybe there's 3 clusters, maybe there's a couple of clusters. It's hard to say. There's 4 variables. So what are we going to do about that? Well, this code here, you can copy and paste this code, and what we're going to do is we're going to build a scree plot for clusters. And what we're going to do is we're going to say, okay, we're going to start with 1 cluster, and we're going to go all the way up to 10. We can go to any number you want, but let's go to 10. And what we're going to do is we're going to cluster these training data set using columns 1 through 4. 1, 2, 3, 4. And we're going to cluster, we're going to put it into n clusters, where n is going to go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we are going to ask the k-means, can you tell us the total within sum of squares? So in other words, how well compact is it? The bigger the number, the less compact these are. So we're going to do that. And then we're going to graph these guys, and we're going to see where there's a natural break. So let's do that. Let's just execute this code. And what R just did is it built 10 clusters, or it just clustered 10 times, first with 1 cluster, then 2 cluster, then 3, etc. Now every time we did this, we looked at the sum of squares error in the cluster, and we dumped them into this guy. So if we type in WSS, those are all of the errors, and you see they go less, they go down smaller and smaller. And the reason why is because the more clusters you got, the less errors you have. But at some point, we're overfitting. We don't want a lot of clusters. We just want as many as we have to have. So let's turn this guy into a data frame. And we're going to call it DFWSS, and we're going to turn him into a data frame. So if I type head data frame WSS, there we go. We've got, well, actually, let's do all 10 of them. There you go. We got all 10 of those guys. Now, how about if we add another column called clusters? We could name it anything, but let's call it clusters. And that will be set from 1 to 10. And now, if we do it again, 1 cluster has this as the error, 2 clusters this, 3 this, etc. Now, let us graph that guy. And there it is. There's our scree plot. And for the clusters, as with the principal components, we're going to just look for places where it sort of starts flattening out. We could go 1, 2, maybe 3, 4, possibly 5 clusters. I don't know. Well, let's try 4 clusters. So now that we've decided on 4 clusters, I've decided to, I've already set that to 4, and we're going to do this again. We're going to now cluster KM here, and we're going to cluster on all 4 variables, and we're going to set it to 4. We should probably do this. We forgot to put that code in. Let's put him there. So now we're going to start with 20 random positions and see which one gives us the best. So let's go here, see the size of the clusters, and what are they? So we've got 38, 35, 21, and 26. We got 4 clusters, and this is their membership, and these are the center points of all of these guys. Now we're going to want to score these people, so we have to take this guy and we have to turn him into a flex clust. That guy right there. So let's turn him into a flex clust. Why? Because if you recall, k-means, whoever invented that, didn't give us a predict command. So we want one of those because we want to score new data. So we have to turn it into flex clust because that guy does have one. So we can turn him into this guy, and then we can use a predict command. So let's do that real fast. And we now have him, or this guy. If I type in AGG, you can see that the clusters are the same. So this first guy here, cluster number 1, the sepal length is 5, sepal width is 3.4, 3.4, 1.4, 1.4, 0.25, 0.25. So you can see here that these guys, when I converted him into a flex cluster, it's still the same. And we could do some plotting. So let's do that real fast just to show you. Here is our box and whisker plots. I'm not a fan of this. It's kind of cool when it's small, but in this case, it's starting to get a little busy and it's kind of hard to see or make any useful inferences from this. I prefer the bar plot, but that's just my personal taste. I think that is more easy to interpret. And also, we could do this image. Now remember, we've got 4 variables, so I could say, let's do an image of 1 and 2. Well, 1 is sepal length and 2 is sepal width. So let's just do that real fast. Oops, that's bar plot. I didn't want to do that. So if we look at, let's do data frame, head, data frame. So if we look at sepal length and sepal width, there's sepal length and there's sepal width, we can see the clusters here. And if we wanted to look at, let's say, let's try this again. I could put a 3 here, and we can now see sepal length and petal length. View both of those guys. So this is kind of a way that we can explore this. I don't find this particularly useful personally, but I just want to let you know that this feature is there. The only one of these flex cluster graphs that I think is useful is, in my personal opinion, the bar plot. Oops. That guy. I find that to be pretty useful. Okay, so now we are going to want to predict using KF, the flex clusters, and we have to train on the same data that we had before. So we trained on this guy, 1 through 4. It's got to be the same size and shape. And if we do this, you can see now that we have a cluster. So we have these setosas and we have these clusters here, 1, 2, 3, 4. And if I want to do a table, let's see how good these clusters are at predicting the species of the flower. Okay, well, you can see that cluster number 1 is perfect for setosis. So if anybody is in cluster number 1, it's an almost perfect guess that this person is a setosa. If they are in cluster number 2, they're probably a versicolor, but they may be a virginica. So cluster 2 is a bit murky as to which of these two it is. Cluster number 3 is almost certainly a versicolor, and cluster number 4 is a virginica. So I could use, if I clustered this and somebody said, well, hey, this flower is in cluster number 3, I would say, well, it's probably a versicolor. Now let's just see how well, now here's our test data, which we've never seen before. Let's predict him. And let's see how well that one predicted. Now remember, we thought that if you are in cluster number 1, you probably are a Setosa. Well, our test data set, we had 12 guys who were Setosas, and they were in cluster number 1. It was perfect. Cluster number 2 was a bit murky between versicolor and virginica. Cluster number 3, almost perfectly versicolor. Look at that. Cluster number 4, almost perfectly virginica. So the point is that the clusters were able to predict the type of flower, even though we didn't train it that way. We just that these clusters can be used for predictive purposes. So anyways, that is irises, and in the next lecture we're going to begin looking at real data.